All right, here we go, Mr. Trutna. We're going to go over Unit 12. This worksheet says Unit 13, but I wanted you to change it to Unit 12. All right, this is Section 2A. This is going to be volume of prisms and cylinders, okay? All right, so first of all, let's talk about, notice right here, it says that we've got our formula for a prism. So the formula to find the volume of a prism is that you're going to take the area of the base, that's what capital B means the area of the base, and then you're going to multiply it by the height of the prism. Okay, so the first thing that you want to do when you're finding the volume of a prism is that, remember, so what makes a you have to think, all right, so what makes a prism a prism? Okay, so remember, so in order for something to be a prism, there's pretty much two things you need to remember. All right, a prism has to have two bases that are congruent and parallel. Okay, so what you're doing is congruent and parallel. Let me catch up with myself here. So when we're talking about a prism, you're looking for a shape. It's going to be a solid shape. A prism is a solid shape, and you're looking for the shape that has two bases that are going to be congruent to each other. That means they're going to be the same as each other, and those two sides are going to be parallel to each other. So if you can find two sides that are exactly the same, and those same two sides are parallel to each other, those would be called the bases, okay? And then the second thing that you have to remember is the height connects the two bases, all right? So the height is whatever the line segment is connects the two bases. It's whatever the line segment is that connects the two bases. So here's what I do. So I look at this shape number one. It says find the volume of each rectangular prism. How do you know this is a prism? Well, it tells you it is a rectangular prism. Now, since it tells you it's a rectangular prism, it's telling you the bases are rectangles. So find two sides that are exactly congruent and parallel to each other, and you can see right here, these are the two sides that I'm going to choose. I will always shade in the two sides in red, all right, and that'll signify which side are the bases. So how do I find the volume? Well, to find the volume, what we do is we find the area of a base, okay, so we find the area of one of the bases, not both the bases, just one of the bases. It doesn't matter which one because they're the same, and then we multiply it by the height of the prism. How do you know what's the height of the prism? Well, the height is going to be, it connects the two bases. So here are my two bases right here. So what line connects the two bases, okay? Well, you can see I've got actually four choices. So that line connects the two bases, that line segment connects the two bases, that line segment connects the two bases, and even that dashed line or dotted line in the back connects the two bases. So how long is that? 24. So my height is 24, okay? Then I need to multiply that by the area of a base. Well, if you notice, the base is a rectangle. All right, so how do I find the area of a rectangle? Well, to find the area of a rectangle, I take the length of the rectangle, which is 17, and I multiply it by the width of the rectangle. So to find the area of the base, I'm going to go 17 times 9. So that means my volume is 17 times 9 times 24. Okay, so in order to find that out, I just get out a calculator, I go 17 times 9, I see what that equals, and then I multiply that by 24. So my volume is 3,672 for number one. 3,672. Then you put the measurements down, which is centimeters, and then you put the cubed symbol there. Volume is always measured in cubic units, okay? All right, number two. So once again, it is a prism, so the first thing that I need to do is I need to identify which two, and you know what, I'm going to zoom this in, so as you're watching this at home, it's a little bit easier to see. I'm going to identify which two sides are going to be my bases. So how do I know what are my bases? Well, my bases have to be two of the sides of the solid shape that are congruent and parallel. So once again, you can see I have the bottom of the shape right here. All right, it is exactly the same as the top of the shape. So I'm shading in the two sides, and this shade isn't great because it looks like I just basically shaded in the whole picture, all right, or the whole prism that I have. All right, so once again, how do I find volume of a prism? Well, what I do is I find the area of a base, and that's denoted by the capital B. Notice area of a base is denoted by capital B in the formula, and then I multiply it by the height, and notice height is denoted by lowercase h. Okay, so let's find it. All right, so what type of shape is one of the bases? Well, if you notice, one of the bases is right here. I'm outlining it. It is, once again, it is a rectangle. So how do you find the area of a rectangle? Well, you take the length of the rectangle, which is 10. You multiply it by the length times the width of the rectangle, which is 14. Then we're going to multiply it by the height. Well, what's the height? Well, the height is a line segment that connects the two bases to each other. All right, so and I have 4 heights in this picture. That line segment would be a height, that line segment would be a height, that line segment would be a height, and that line segment in the back would be a height. How long are those? Well, they are 4. So that means my height is 4. So then my volume is going to be 10 times 4 times 10 times 14, excuse me, times 4. Okay, so I go 10 times 14, then I multiply that by 4. I don't have to press equals after 10 times 14, and I get 560. There we go. You can't see that right there. So my volume is going to be 560 for number 2. Okay, so after you write down the measurements, the numbers, the numerical value, put down the measurement, which is inches, and then remember volume is always to the third power, or to the cubic unit. So number 2, 560 cubic inches. Okay, number 3, all right, so I need to find the base, and in this case right here, my 2 bases are going to be the front of the shape, which is right here, and if you notice, the front of the shape is exactly the same as the back of the shape. So once again, how do I find volume? Well, I find the area of the base, that's denoted by capital B, and then I multiply it by the height, and height is denoted by lowercase h in the formula. Okay, so let's find it. So what type of shape is the base here? Well, if you notice, my base of this shape, I'm going with this part. I'm saying this part right here. This is one of my bases, and then the side right behind it, which is exactly congruent and parallel to it, is a base. So what type of shape is that? That's a rectangle. How do you find the area of a rectangle? We would take the length, 39, and then we would multiply it by the width, which is 12. So the area of the base is going to be 39 times 12, and then I multiply that by the height. So the height is going to be a line segment that connects the 2 bases together. So that would be a height right there. That would be a height. I'm saying my bases are the front and the back of the shape. So all of these line segments here that I just outlined in red, hopefully you can see them. Yeah, you can. Okay, those would all be my height. So what's my height? My height is 8. So my volume would be 39 times 12 times 8. Okay, so when I work that out on my calculator, so I'm going to go 39 times 12. Can you see that? Yep, it's way up there in the right corner. And then I multiply that by 8. So my volume is going to be 3,744. Okay, so 3,744. Then we put the measurements, which is feet, and then it's always to the third power, or cube. So there's my answer to number 3. Okay, moving on to number 4, 5, and 6. 4, 5, and 6 are a little bit different because the bases in this problem is going in 4, 5, and 6. They're not going to be rectangles. They're going to be some other shape. Okay, so when I'm looking at number 4, I have to find the bases. So the volume formula is still the same. We're still going to find the area of the base, which is denoted by capital B once again. We're still going to multiply it by the height of the prism, and the height is going to be the side. So I got to find the bases. There's going to be 2 of them. So when we're finding the bases, we're trying to find the 2 sides of the shape that are parallel to each other and are congruent. And if you look closely, you will notice that this triangle, which is the top of the shape, is exactly the same as the bottom triangle down here. Okay, so those 2, and I'll shade one of them in right here. So that which is the bottom is exactly parallel and congruent to the top. So those are the bases. So that means any line segment that connects the top and the bottom, which are my bases, that line segment, or that line segment, those are my heights. So my height is 5 in this prism. Okay, so my height is going to be 5. Then, now I need to find the area of the base. Well, what type of shape is the base? Well, the base is a triangle. Okay, so what I need to do is I need to find the area of this triangle here. So what I'm going to do is I'm going to take this base right here and I'm going to draw you a picture of what it looks like. So if you notice, it is a triangle, and if I drew it out and I flipped it around, here is what the base looks like. We've got this dotted, or it's a dotted line, but that's that line right there. It is 7 feet, so I'm just going to put a 7 right there. Then we've got the two sides are 5 and 9, so this is 5, this is 9 here, and that right there is a right triangle. Okay, and then if you notice also, well, then we have we have a 10 and we have a 12 and we have a 9, so I messed up right there. So if you notice the triangle right here, one side is 9, the other side is 10, and then the third side is 12 right here. Okay, so now, so I need to find the area of that shape. That's going to be my base. So how do you find the area of a triangle? Well, remember, to find the area of a triangle, you take the base of the triangle, you multiply it by the height of the triangle, and then you divide it by 2. So in this triangle, how long's the base? It's 12. Okay, what's the height of the triangle? It's 7. So I'm going to go 12 times 7, and then I'm going to divide it by 2. So my volume formula is the area of the base, which is 12 times 7 divided by 2, and then I'm going to multiply that by the height, which is 5. Okay, so then we work this out. 12 times 7 is 84. 84 divided by 2 is 42, so I'm going to get 42 here, and then I'm going to multiply that by 5. Okay, I could do this one in my head, so it's going to be 210 for the volume. The measurement is feet, and then I put cubed. So the volume of this prism is going to be 210 cubic feet. Okay, moving on to the next problem, we have number 5. Notice it's a prism again. So I want to find the bases. So I want to find the volume. So the formula for the volume is find the area of the base, multiply it by the height of the prism. So to find the base, remember a prism is always going to have two bases. And the bases are going to be the two sides of the prism that are exactly the same and are parallel. And if you notice, the front here, which is this triangle, is exactly the same as the back of the shape back here. So the back of the shape is this triangle as well. So that means when I find the area of the base, I'm going to have to find the area of this triangle here. And I'll draw a picture of it. So what does the base look like? Well, once again, it's this triangle here. Okay, so it looks like this triangle. So we've got this side going along here, which is 12. Then we've got this side going up like that. And if you notice, that side is the same as that, so that means that has to be 6. Then we've got this side going here, okay, and if you notice, that's the same as that, so that is 10. And then we've got this dotted line going right down perpendicular with the base, and that is 5, okay. So to find the area of the base of a triangle, once again, what we do is we take the base of the triangle, which is 12, we multiply it by the height of the triangle, which is 5, so we're going to go 12 times 5, and then we divide it by 2. Okay, remember, for a triangle, base times height divided by 2 gives you the area. Okay, so that would be 12 times 5 divided by 2. Then we're going to multiply it by the height. Now, h stands for the height of the prism, not the height of the base, so the height of the prism. So remember, the height is any line segment that connects the two bases. So that would be a height, that would be a height, that would be a height. How long are any one of those three? 16. So the height is going to be 16, okay? So then I work this out. 12 times 5 is 60. 60 divided by 2 is 30. Then I'm going to go 30, and I'm going to multiply that by 16, okay? So I get out a calculator. I'm doing the calculator off to the side over here. You can't see it, but 30 times 16 is 480. So my volume is going to be 480. That's my numerical value. Put the measurements, which are millimeters. This is a typo right here. That's going to be millimeters. There's no way I would give you a problem where you have to convert inches into millimeters. And then it's going to be 480 millimeters cubed. I apologize about that typo right there. Okay, hopefully you catch it as you do the problem. Okay, moving on to number, oh man, got to pay the energy bill. Okay, woo, the generator kicked on right here. Thank goodness there. Okay, so then we have number 6. So we're finding the volume of number 6. So once again, to find the volume, we find the area of the base, then we multiply it by the height of the prism. Okay, so what type of shape is the base? So remember, a prism always has two bases. So where you are finding two sides in this shape that are exactly congruent and parallel. And if you look close enough, you will notice that that side right there, okay, which is a trapezoid, I just outlined it, it's exactly the same as the back of the shape. So my bases are going to be these trapezoids right here. So this is what my base looks like. And this is what I'm going to have to find the area of. So I'm going to have this trapezoid where I have this line right here, which is 36 meters. So I'm just going to put 36. I'm not going to worry about the measurement. Then I have that side right there, which is like that. And notice that is 8. Or no, that's not 8, because this 8 has this arrow right here. So that side's not 8. Okay, it's this side here. Then I have another side that goes like that. Okay, and all that I know that these are equal, and I know that because of those tick marks, and these are 21. So that's 21, and that's 21. And then I have this bottom part, which is 14. Okay, and then I have this dotted line going like this, so that it's perpendicular, so that indicates to me that that's the height, and that the height is going to be 8. Okay, so to find the area of the base, which is capital B, I need to find the area of this trapezoid. So how do you find the area of the trapezoid? Well, remember the formula for a trapezoid is you take one of the bases, you add it to the other base, so base 1 plus base 2. So you add up the two bases, then you multiply it by the height of the trapezoid. Now remember, that h is different than that h. That's the height of the prism. This is the height of the trapezoid, and then you divide by 2. Okay, so to find the volume of this prism, I need to use this formula to find the area of the base. So it would be base 1, 36, plus base 2, which is 14. In a trapezoid, the bases are the two parallel sides. Then I'm going to multiply that, 36 plus 14, then I'm going to multiply that by the height of the trapezoid, which is 8, and then I'm going to divide that by 2. So all of this, 36 plus 14, that result multiplied by 8, that result divided by 2, that's going to give me my area of my base. Then I'm going to multiply that by h, which is the height of the prism. And then remember, the height is going to be any line segment that connects the two bases together. So all 4 of these line segments here that I'm outlining in red are the heights. How long are they all? Well, you can see they are 25. So the height is going to be 25. Okay? So then, once I get this, I'm just going to work this out on my calculator here. So I'm going to put this out so you can see how they do this on my calculator. So I'm going to go 36 plus 14. Plus 14, I'm going to see what that equals. That's 50. Then I'm going to multiply that by 8. Multiply that by 8. That's 400. Then I'm going to divide that by 2. Okay, so that means all of this turns out to be 200. So the area of the base is 200. Then I'm going to multiply that by 25. And that's going to give me my volume of this shape. So times 25. And I get 5,000. So my volume of number 6 is going to be 5,000. Then I put the measurement down, which is meters, and then volumes measurements are always in cubic units. So 5,000 cubic meters for number 6. Okay, turning it over, notice we have number 7 now. Okay, so number 7, we're finding the area of this prism. So once again, the formula of a prism is you find the area of the base, denoted by capital B. You multiply it by the height of the prism, which is denoted by lowercase h. So let's find the bases. Prisms always have two bases. You can see that the two bases, the two sides that are perfectly congruent and parallel to each other, are these two sides right here, which I'm outlining in blue. So those are my bases, and this one I could even shade in because it's really, they're not overlapping, so it's easy to see. Okay, so that means my base, my area of my base. I have to find the area of these triangles. So here's what my triangles look like. I've got this line right here, which is 24. I've got this side right here, which I don't even know how long it is, so I'm going to have to leave that. And then I've got this side right here, which, as you notice, is 30. Okay, and then we have right angles, so we have a right triangle here. Okay, so how do you find the area of a triangle? That's going to be my capital B. Remember, a triangle is the base of the triangle times the height of the triangle divided by 2. Okay, well, the base of this triangle, I don't know what it is. The height of this triangle is 24. So when I find the area of the base, I'm going to go something, I don't know what that is, I'm going to leave that blank. Then I'm going to multiply it by the height is 24, and then I'm going to divide by 2. So I'm going to go something times 24 divided by 2. We need to find that something. We need to find this right here, the base of the triangle. How do I do that? Well, it's a right triangle, and I know two sides, so I'm going to use Pythagorean theorem to find the base of the triangle. So hidden in this problem is you got to know Pythagorean theorem. So what's Pythagorean theorem? Well, it's one of the legs, which is b squared, plus the other leg of the right triangle, which is 24 squared. That's going to be equal to the hypotenuse, which is 30, and then squared. So I need to do Pythagorean theorem to find the base of my triangle, to find the area of my triangle, which is going to be the area of my base. Okay, so I need to work this out here. All right, so I simplify it. B squared you can't simplify, plus 24 squared becomes 576. That's going to be equal to 300 squared, and 300 squared is 900. Okay, so then I subtract 500, I'm solving this problem out for B, so I subtract 576 from each side of the equation. 900 minus 576 is 324. So I get b to the second power is equal to 324. And then, remember, if you know that b squared is equal to 324, to find b, mathematically, you take the square root of 324. So the square root of 324 is 18. So that means my base of my triangle, which is the base of my prism, is 18. So to find the area of the base, I'm going to go 18 times 24 divided by 2. Then I'm going to multiply it by the height of the prism. So the height is any one of these lines, that line segment, or that line segment, that connect the two bases. And you could see that would be 35. So we would say the height of the prism is 35 there. Okay, so now once I do that, I just work this out on my calculator. So I'm going to go to find the volume. I'm going to go 18 times 24. Okay, 432. Then I'm going to divide that by 2. So that's 216. And then I'm going to multiply that by 35. So you can see I get 7,560. That's my numerical value for the volume. I put the measurements in, which is kilometers, and then volume is always cubic measurements. So 7,560 cubic kilometers there. Okay? All right, so number 8. Once again, we have a prism right here. So, number 8. So we need to find the bases. So volume for any prism is the area of the base, denoted by capital B, multiplied by the height of the prism, denoted by H. So let's find what type of shape are the bases. There's always two bases in a prism. So if you notice, the front right here is exactly the same as the back. And I'm not going to shade them in, but you can see the back right here. They're both exactly the same, and they're parallel. So they're the only two sides in the shape that are congruent and parallel. So that means this would be considered my base. Okay, so what type of shape is that? Well, that is a trapezoid. All right, so let's draw it. So here's what my base looks like. So I have this line right here, which is 24. Then I have this line going this way. And I got to look at the shape to see if I know it at all. So I don't know that. I don't know that. So I'm going to have to leave that blank for now, I think. And then I have this line going up, which is 40. So I have this line going up, which is going to be 40. And then I have this line right here, which is that line, which is the same as that. So that's 30. Okay, and then I don't have anything else. Okay, so I have 24 and 30 right here. But I do have this 35 right here, which I believe if, and I don't know if this problem was specific about it, but this is gonna have to be, so if that's 35, I'm assuming, and I'm not 100% sure if it's right or not, but I'm gonna go with it, is also gonna be 35. So I'm gonna assume that that's 35 as well. So I'm assuming this bottom is going to be a square here, so that is going to be 35. Okay, so I have to find, so to find my capital B, which is the area of the base of the prism, I have to find the area of this trapezoid. So once again, the formula to find the area of a trapezoid is you go base 1 plus base 2, then you multiply it by the height of the trapezoid, and then you divide by 2. So to find the area of the base of the prism, I'm going to go base 1, which is 24, plus base 2, which is 40. Remember, in a trapezoid, the bases are always the two parallel sides. Okay, I'm going to go 24 plus 40. Then I'm going to multiply that by the height of the trapezoid. The height is 35 right here. Has to be, because that's a 90-degree angle there. See, 90 degrees. So the height is 35. And then I'm going to divide all that by 2. So 24 plus 30 times 35 divided by 2, that's going to give me the area of the base of my prism. Then I'm going to multiply that to find the volume by the height of the prism. So the height is any line segment that connects the two bases. And I actually have 4 heights in this prism here, all of those right there, which I just outlined in red, okay? And you can see, so I'm going to say the height is 35 there, okay? So we have that. All right, so now once I get that, now I just use my calculator to find the volume. So I'm going to go 24 plus 30, 24 plus 40, excuse me, that's 64. Then I'm going to multiply that by 35. That's 2,240. Then I'm going to divide by 2. So I get that. So all of this right here becomes 1,120. Then I multiply it by the height of the prism, which is 35, and that'll give me my volume. So my volume is 39,200. That's my numerical value. Put in the measurements, which is centimeters and cubic. So we have 39,200 cubic centimeters is the volume of that prism right there. Okay, all right, moving on to number 9 and 10, we're dealing with cylinders. So cylinders are not prisms, so it's a different shape. Okay, and you should recognize a cylinder when you see it. The top and the bottom are always going to be circles, and then we're going to have the height. So to find the volume of a cylinder, we're going to take pi. Okay, we are going to multiply it by the radius, which in number 9 is 18. And it's always going to be the radius to the second power, so it's going to be pi times 18 to the second power, and then we're going to multiply it by the height. And the height of a cylinder is always the line segment that connects the top and the bottom together, or the two circles together. Okay, should have said the two circles together. The two circles are always the bases. So the height is the line segment that connects the two bases, and in a cylinder the bases are always circles. So the height would be 15. Okay? So then I work this out, all right? Pi, remember, it's a Greek symbol, and it's a Greek symbol for a number, and we're going to use 3.14 for the symbol pi, okay? And we know it's not 3.14 because remember, the number pi actually is just a continuous number. It goes on forever. But to work this out, I'm going to go 3.14, then I'm going to multiply it by 18 to the second power. And you can see on my calculator here, I'll go ahead and work it out so you can see it. So 18 to the second power is 324. And then I'm going to multiply that by 15. Okay, so 3.14 times 324 multiplied by 15. There is my volume of that cylinder, 15,260.4. Okay. Put down the measurement, which is inches, and then volume is always in cubic measurements. So there's my volume for number 9. All right, now when you're working with a cylinder, please be aware you're probably almost always going to get a decimal for an answer. If you get a really long decimal in your answer, just go ahead and round your answer to the 10th spot. Okay, this problem happened to end right at the 10th spot, so I didn't have to round. But if you get more decimals, just round to the 10th, which is the first space value after, to the right of the decimal. Okay, number 10, once again, we have a cylinder. Should be pretty easy for you guys to recognize a cylinder. It's a solid where it's got two circles. The circles are the bases. So to find the volume, I take the number pi, I multiply it by the radius. Okay, so right here, if you notice, this would be my radius right here, just from there to there. That whole thing is 12, so that's a diameter. So what's my radius? It's half of it. So my radius would be 6. So it would be 6 to the second power multiplied by the height, and the height is always the line segment that connects the two bases. And the two bases in a cylinder are circles, so you can see the height is 21. Okay, so I'm going to go pi times 6 squared times 21. Simplifying this out, pi, we're going to use the number 3.14. Little bit inaccurate, so really our final answer is not going to be an exact answer. It's just going to be an approximate. 6 to the second power is 36. Then we're going to multiply by 21. Okay, so multiplying this all out, 3.14 multiplied by 36 multiplied by 21, I get 2,373.84, and like I was just talking about in the previous problem, I'm just going to say 0.8. Okay, the 4 would not round the 8. I'm always rounding to the 10th spot. The 4 would not round the 8 up to a 9. Put the measurements, which are meters cubed. So there's my volume of this. Now, a couple of things, or one thing that I did want to point out, I do know that some of you guys have a, instead of 3.14, I've noticed that some of you guys have a pi button actually on your calculator, and if you do, that is fantastic. You can see this calculator has a pi function right there. So if I multiplied out pi times 36 times 21, watch what happens. I get 2,375.044046. But if I go 3.14 times 36 times 21, notice the difference in the answers. They're slightly off, okay? So just know that if you're using the pi button on your calculator instead of 3.14, you're going to get an answer that's slightly different than what I'm saying the answer is. But don't freak out if that happens. Just know, okay, you're close to the answer. And the reason why is because is your calculator using 3.14 for pi? The answer is no. Heck, I don't even know what your calculator is using for pi. Obviously, it's using a lot more decimals other than 3.14. Okay, but just be aware of that, okay? Number 11, a cylinder with a 2 centimeter diameter is drilled through the triangular prism shown on the left. So if you notice right here, we have this cylinder, but then we have this prism. We have the cylinder, it's drilled out. So there's like a hole inside this prism. Find the volume of the prism. So here's what we have to do. We have to find the volume of the prism, and remember a prism volume is area of the base times the height, and then from that we have to subtract out the volume of the cylinder, and remember the volume of a cylinder, we would subtract it out, is pi times radius squared times the height of the cylinder, okay? So there's really two problems we have to do here. We have to find the volume of the entire prism as if there was no cylinder drilled out of it. Then we find the volume of the cylinder, and we have to subtract it out because it's been drilled out of it, okay? So let's find the volume of the prism. So if you notice, the prism right here, the top and the bottom are exactly the same. And I'm outlining them. They are both triangles, okay? So I have to find the volume, and then we have a right triangle here. So I have to find the area of the base of one of these two triangles, okay? So how do I do that? Remember, here's what my base looks like, and I'll draw it over here for you so you can see it. So my base is this triangle where that side is 5, that side is 5, and then we have a right angle. And then that side is that, which is 7. Okay, so I have to find the volume of that. So how do you find the area of that? So how do you find the area of a triangle? Remember, it's base times height divided by 2 of the triangle. So in this case, the base and the height are 5 and 5. Okay, how do I know that? Well, a height always has to be perpendicular, make a 90-degree angle with the base. So that means 5 and 5. So to find the area of the base of the prism, I'm going to go 5 times 5, divide it by 2, then I'm going to multiply it by the height of the prism. So the height of the prism is this line right here, or that line right there, or even that line in the back, which is 14. Okay? So then I'm going to go 5 times 5, that's 25. I'm going to go 25 divided by 2, and then I'm going to multiply that by 14. And I'm doing it off screen on my calculator, but you could work it on your own calculator. So I get 175. Okay, so that 175, well, that's not my answer. That's the volume of the prism. Now I need to subtract out of that the volume of the cylinder because it's been drilled out. So remember, for a cylinder, I'm going to go pi. Then I'm going to multiply it by the radius. Well, what's the radius of this little circle right here? It tells us right here. It's got a 2 centimeter diameter drilled through the prism. Okay, so the diameter is 2 centimeters. So what does that make the radius? Remember, radius is half. So the radius is going to be 1 squared times the height. Well, the height of the cylinder is the same as the prism, which is 14. Okay, so I'm going to multiply this out, and I'm going to subtract that out. So multiplying that out, I'm going to use 3.14 for pi. I'm going to multiply that by 1 squared, that's 1, and then I'm going to multiply that by 14. And I get 43.96. Okay, that's not my answer. That right there, that's my volume of my cylinder. So then I subtract the 2, okay? So 175, and I'll move it over here so you can see it a little bit better. Can you see it? Let's see. Yep, 175. I'm going to subtract out of it 43.96, which is the cylinder. So that means my volume is 131 point, and then remember, I'm rounding to the 10th. So would that 4 change that 0 to a 1? No. So I'm just going to say 131.0. Kind of stupid. I should have just said 131. Then I put the measurements, which is centimeters cubed. So that's the answer to number 11. Okay, last one, number 12. A diagram of Eric's pool is shown on the left. So this is Eric's pool right here. Kind of a weird shaped pool, but I guess it could be one of those outdoor, like above ground. They call those above ground pools. Back in my day, they called it like an adobe pool. I don't know why. He plans to fill his pool to a depth of 4 feet. So he's going to fill this sucker up so that it's 4 feet deep with a garden hose that has 80 cubic feet per hour flow rate. How many hours will it take to fill the pool? Okay, well, guys, this is a great problem because I don't know if you've ever had a swimming pool put in your backyard. I remember my parents did it when I was like 9 years old, and the most painful part of the whole experience was when the entire pool was done, and then we had to fill the sucker up with a garden hose, and it took forever to do it. Not really forever, but to a 9-year-old, it took forever. It took hours and hours and hours. Okay, so how are we going to do this? Well, first of all, we have to find the volume of Eric's pool. The volume tells us how much water is going to go in the pool. Then we have to figure out how long would it take if it fills up at 80 cubic feet every hour per hour. Okay, so how do we find the volume of a cylinder? Well, the formula is take the number pi, multiply it by the radius to the second power, radius squared, multiply it by the height of the cylinder. Okay, do we know what pi is? Yes, 3.14. The answer is no. If you said yes, shame on you. We don't know what pi is, but we're going to use 3.14. Do we know the radius of this cylinder? Yeah, we do. The radius is always just from the center of the circle to a point on the circle, which would be half of the diameter. So we know the radius is 13. We're going to square that. Do we know the height of the cylinder? Yeah, the height is the line segment that connects the two bases. In a cylinder, the bases are circles, so my height is obviously 4. So to find the volume, I'm going to go 3.14 pi, or almost pi, not really pi, times 13 squared, and that's what's 13 squared. I could type it out like this if I wanted to. I could go 13 squared, and then I'm going to multiply that by 4. Okay, and I get 2,122.6. I'm not going to say 0.64. So my volume is 2,122.6. Okay, and then it's going to be feet cubed, or cubic feet. So that's my volume. The problem did not ask for the volume. The problem asked for how many hours will it take to fill the pool. Well, we know that the garden hose, we're filling the pool with one garden hose. It fills the pool at 80 cubic feet per hour. So I want to know how many 80 cubic feet are there in this. So what am I going to do? Well, to figure out the time, I'm going to take the volume and then I'm going to divide it by 80 cubic feet, okay? So I take 2,122.6, and I'm just going to leave it like that, why not? Yeah, and then I'm going to divide it by 80. Hope you can't see that. So I'm going to take the volume, which I never cleared off my calculator. I decided, oh, whoops, now I really messed myself up. 2122.6, and I'm going to divide it by 80. Why am I dividing by 80? Well, because the garden hose puts 80 cubic feet of water in it. So this is going to take 26.5 hours, okay, to fill this thing up. So this thing gets done on Friday at 8 a.m. We're not swimming till Saturday at 8:30 a.m. Okay, and then it's cold when you're swimming. But anyhow, there's your problems.